Hi everyone, my name is Preeti. Pursuing my education in Sri Venkateshwara College of Engineering, Bangalore. So this is a control system. So in control system, we'll learn about transfer function in block diagram. So in block diagram, transfer functions are a powerful tools used in a control system engineering to represent and analyze the behavior of systems. So next we'll understand the block diagram components. So first one is block. Represent mathematically operations or a system components. They take an input and produce outputs based on a specific transfer function. So arrows indicate the direction of a signal flow and connection between blocks. Arrows represent the movement of the signals through the system. So next summation points represent the algebraic summations of incoming signals. They are used to combine signals before they enter a block in a transfer functions. So next we will see process of input, output and system elements. So first one input, the signal or disturbance that enters the system. It represents the starting point for the system analysis. So the next output response of the system of the input, if it represents the design and measure outcomes of the system operation in output. So next system element, the components or process within the system that affect the relationship between input and output. So next feedback loops, connection that allows the output to influence the input, closed loop of the system in a feedback. So this is the process of the input and output of the computer system. So next we'll see representing feedback loops. First one, forward path. The primary path from the input to output representing the system direct response. So next feedback path. The path that takes the output signals back to the input creating the closed loop system. So next summing junction. The point where the feedback signal is combined with the input signals. So next we'll see how to simplifying the complex block diagram. First one, block reduction, combining blocks in a series, parallel or feedback configurations using algebraic manipulations. So next signal tracing, following signal path and identifying key transfer functions to understanding overall system behavior. So equivalent diagrams, creating simplified representation of the block diagram that capture essentially system dynamics in a transfer function. So next we'll analyze the system of stability of the block diagram. Stability criteria. Evaluating the system response to disturbance and determining if it remains bounded or diverged over time. Next, root locus analysis. Visualizations the location of a system, poles and zeros on the complex plane to determine stability. Frequency response analysis. Studying the system response to sinusoidal input at the various frequency to access stability in a block diagram. So next, applying block diagrams to control system. Modeling representing the system mathematically used in a transfer functions. And next, control design. Designing a controller achieve desired performance characteristics such as stability, accuracy, and speed. So next, simulation, testing the design system using simulations to validate its performance and make adjustments. So next, implementations in a block diagram, which implementing the controller in a real world system and verifying its performance in a control system. So this is an example of the transfer function of the block diagram. So now this is the R of S and this is the C of S. We have to find R of S divided by C of S. For reducing the block diagram, first we have to reduce the block which connected in a series and which connected in a parallel and reduce the minor internal feedback loops in a block diagram. As per possible, try to shift takeoff point to the right and the summing point to the left. Unless unless until the requirements of the problems, we do not use the uh, summing point which repeats the step parallel series and feedback loops, we have to reduce the minor. So this is the first step, which this is in a parallel, so we have to do in a series. So this G1 is connected to the H1 and H2 and H3 is connected to the this summing point. So now reduce to the we have to reduce summing point, and we have to reduce it is in a parallel, so we have to convert into a series. So after series we have to multiple G1 into G2 divided by 1 plus G1 into H2, which is connected to the H2. After multiplying, again we have to solve by 1 plus G2 into H3, and which is connected to the summing point H1 into H2. So after multiplying H3, we will get the G1 into G2 and divided by 1 plus G1. So G2 H2 plus G1 into G2 plus H3. After this, we have to take C of S, again one summing point, and R of S. In that, what we will get in this G1 into G2 divided by 1 plus G1 into G2 into H2, which is connected to the H1 and H2. Again, we have to multiply H1 into H2. So the final answer will be G1 into G2 divided by 1 plus G1 G2 H2 plus G1 G2 H3 plus G1 G2 into H2 into H1. So this is a example of the block diagram. Thank you.